Hi there. In this video, we're going to talk about computing probabilities using a contingency table. So this is another way of displaying information from which we want to get probabilities. So let's take a look. So here we have results of a survey that asked 1,048 U.S. adults whether they supported or opposed a special tax on junk food. A person is selected at random. Find the probability that the randomly selected person has these traits. Okay, so what's the probability that they oppose the tax? Right, so A. Well, how do we do this? Well, we look at the number of people that oppose the tax. How many? There are 325 males, 300 females, but in total there were 625 people that opposed the tax. So that's 625 over the total number of people in the sample, 1048. Okay, let's go to part B here. Is unsure about the tax. Well, how many people were unsure? There were a total of 27. So 27 out of a total of 1048. So that's the probability of being unsure. Okay, what about opposes the tax or is unsure? Okay, well, what we can do, we know that the probability of opposing or unsure, we know the probability rule for or is the sum of the probabilities minus the probability of both having occurred, right? So let's look at the probability that they oppose the tax. That is 625 out of 1048 plus the probability that they're unsure. That was what we computed here, 27 out of 1048. And now that addition rule says that we have to subtract the probability that they're opposing the tax and are unsure. So to oppose and be unsure, well, you can't oppose and be unsure. Those are two different opinions. So that probability is 0. So we can simply just add those. And so we see the answer is 652 out of 1048. That's our probability. Okay, let's look at D. Probability that the person is male. Okay, well, how many males are there? There are 493. And how many people are there? 1048. Well, there's the answer. Okay. What about the probability of being male and opposing the tax? I'm going to put it over here to save space. E. Male and opposes the tax. So male and opposes. So that means not only are they male, but they also oppose. So there's only 325 people that are both male and oppose, right? 325. And a total of 1048. And part F. What's the probability that they oppose the tax or are male? Well, okay. What's the probability of opposing the tax? Well, that is 625 out of 1048. We did that before. The addition rule says we add the probability that they are male, which is what we computed in part D, 493, 1048. And then we're supposed to subtract the probability that they oppose the tax and are male. Well, that's what we computed in part E. So I subtract 325 out of 1048. And what do we get here? We get 793 out of 1048. And just two more, just so that we understand the given that condition. We're going to look at these. What's the probability that the person opposes the tax given that they are male? Okay, well, given that they are male, so we are assuming that they are one of these people. So what that does is it changes our denominator, because now we're only looking at a possible 493 total people. the males, right? So the probability for A is going to have a denominator 493. And what's the how many of them oppose the tax? Well, of these people, there are only 325 that oppose the tax. So this is how we would answer A. So notice that when it says given that, we have a new denominator. It's changing the total. Whatever comes after given that is describing the new total. So instead of using 1048 like we did in the previous problems, we use the total number of those people, males. Okay, let's look at B. Are female given that they are unsure. So given that they are unsure means we're restricting our attention to these people, the 27 total. So we know our denominator is 27. How many of them are female? Well, there are 22 that are female. So that's the new probability.